Let's go to page 350 and let's start with number 554. Okay, so if both x and y are integers, how many solutions are there of the equation x minus a, x minus 10 is equal to 2 to the y? Okay. So this one is kind of a little bit hard to do if you do it straight. So I'm going to let z equal to x minus 8. And so that way, this becomes z times z minus 2. And then after that, we can go and solve. So we make a table. So if y equal to 1, this would be 2 to the 1, so equal to 2. Okay? And so this has to off by 2, right? So again, there's no solution for that. So when y equal to 2, you get 2 squared, you get 4. Okay? And so again, there will be no two numbers will give you a product of 4 with a difference of 2. Okay? So when you get z, so y equal to 3, so you got 2 to the 3 power will give you 8. Okay, so in this case, you're going to get 4 times 2, right? So 4 times 2, so you can see that z equal to 4, and 4 minus to give you 2, right? But you also, when you have 3, 8, right, you also can have the negative 2, negative 4, okay? So when z equal to negative 2, z minus 2 will give you negative 4, so this will also give you 8. So this is good, okay? And when you go to 4, 2 to the 4 is 16, and 16, there's no two numbers that are different by 2. Remember, they are off by 2, right? Different by 2. So that's nothing you can multiply. And when you get to 5, 2 to 5 is 32. And so 32 would be 4 times 8. By the time you 8 times 4, so notice the difference is greater than 2 already. So anything when you continue on, the difference is going to be more than 2. Okay? So that's going to be none after that, because again the difference is going to be more than 2. Okay? So only 2 that will work would be this 2 over here. So once you find this 2, you can solve for the x and the y, right? Okay. So the y is already done. So you can look for the when z equal to 4, and so 4 minus, so z is equal to 4, and then you substitute, so you can x equal to, so over here you're going to get x equal to 12, right? 4, so you got 4 plus, so 4, and you move it over, so x equal to 12, 3, and this one would be, so z is negative 2, so it would be 6, 3. Okay. So you can use this equation over here to get the x. So z equal to x minus 8. So you got 4 equal to x minus 8. So x equal to 12. Okay. And same thing over here for the negative 2. So you got negative 2 equal to x minus 8. So plus 6, plus 8. So you got x equal to 6. So that's how I get these two numbers. Okay, let's go to the next one. Okay, so 555, it says Sam needs 5 different instruments for his band. He found 5 people, each of whom can play 2 instruments. If 2 people can play the same 2, if no 2 people can play the same 2 instruments, and each instrument can play by exactly 2 people, in how many ways can Sam form his band from 5 people? Okay. So in this case, what you do is you let people be A, B, C, D, and E, and instrument instrument be V, W, X, Y, Z. Okay. And because they are all, they are kind of random, so you can just that A can play V and W, and that B can play W, X, C can play X, Y, and D can play Y, Z, and E can play Z, V. Right? So again, A have two choices. Now once you determine A, let's say A plays V. Let's say A plays W. Okay? That means this one have to play X. That means this person will have to play Y, and that means this person have to play Z. That means this person have to play V, right? Now, if you do it the other way around, okay, if A plays V, okay, then E have to play Z, and then D have to play Y, then C have to play X, and so forth. Okay, so whatever instrument that A played determine everybody else. So in this case, there are only two choices. Okay, so there are only two ways that you can form this band. Okay, let's go to the next one. Okay, so 556. Let x equal to square root of 2 plus square root of 2 minus 2 minus square root of 2. And you're looking for 384 x squared minus x to the 8. Okay, so first, let's go and square both sides since we're looking for x squared, right? So let's go and square both sides. So you get x squared equal to, when you square both sides, you square that, you get 2 plus square root of 2. And then the middle term would be plus 2 times square root of 2 plus square root of 2 would be, or there's a minus, so it would be minus 2. Minus 2 times this, and 2 minus square root of 2, and then you square that, so plus 2 minus square root of 2. Okay, so notice that this will cancel out. Okay. So x squared will equal to, there's a so there's a 2 and 2 in here, so it would be a 4, and be minus 2 square root of, now this is conjugate, so when you multiply, you're going to get 4 minus 2. Okay. And so x squared will equal to 4 minus 2 square root of 2. Okay, so we got x squared. Now we're going to square this again. So x squared equal to 4 minus 2 square root of 2. So square both sides again. So x to the 4 will equal to 16 minus, so multiply all this together, get 16 square root of 2 plus, so square this is 4, square this is 2, so it will be plus 8. So x to the 4 equal to 24 minus 16 square root of 2. Then we're going to square this one more time. So x to the 8 will equal to 576 minus 768 square root of 2 plus 512. Right, again, you square that, you get that. Multiply all this together, you get that. And you square that, you get that. Okay, so x to the 8 equal to 1088 minus 768 square root of 2. Okay, so now we can go and substitute into here. Okay, so 384 x squared minus x to the 8 will equal to 384. X squared is 4 minus 2 square root of 2 minus this over here will be 1088 minus 768 square root of 2. So this will equal to, go and work it out. You're going to get 1536 minus 768 square root of 2 minus 1088 plus 768 square root of 2. And this cancel out, so that's kind of nice. So all you have to do is this minus that, so it equal to 448. Okay, let's go to the next one. Okay, a set of 17 points is choosing on the circumference of a circle. Okay, so you got points, 17 points on a circle. Find the maximum number of segments which can be drawn connecting pairs of points such that each segment intersect all the other inside and out on a circle. Okay. So maximum number of segments which can be drawn connecting pairs. So connecting pairs, what you can do is, if you just go like this, okay, for example, then they will all intersect inside, okay. And since there are 17 points, and you take two, so you take 2 points to make a segment, right? So this only can maximum of 8 pairs of points. So you can make 8 pairs of points. So another 8 segments. So another way you can make 8 segments. So one of the points is going to get left out, okay? And so you're going to be able to make 8 pairs. Okay, so answer would be 8. Okay, so you can make 8 pairs. Okay, let's go to next one. Okay, 558 says find the solution of you got 2 to the 2x minus 3 to the 2y equal to 55. Okay, and so x and y are integers. Okay, so first let's go ahead and rewrite this over here. So you got 2 to the x square minus 3 to the y square. So again, I'm just put this in a different form. Okay, and you can check, right? Exponent of exponent you multiply, so 2 times x give you 2x, 2 times y give you 2y, right? Then from here you can go and do the factoring. Okay. And then from here you can go and also break these things up. Now notice the plus is in the front, so I'm going to write it this way. Since this is plus, it has to be a bigger number, so it will be 55 times 1. Okay, or another possibility, we equal to 11 and 5. Okay, so these are 2 possible combinations. So from here you can go and set matching it to each other, right? So you got 2 to the x plus 3y equal to 55, and you got 2 to the x minus 3y equal to 1. Okay, so I'm going to move this, put this under here to eliminate the 3 to the y. So you add, so you get 2 times 2 to the x equal to 56. Okay, and you divide by 2. Okay, so this one is no good because remember x and y are integers, so there's no integer that will give you 2 to the integer give you 28. Okay, because 2 to the 4 will give you 16, 2 to the 5 will give you 32. So there's no integer that give you 28. So this one is out. So now we can focus on this one here. So you got 2 to the x plus 3 to the y equal to 11. You got 2 to the x minus 3y equal to 5. Put this under here. And then you add. So you can put this under here. So you get 2 times 2 to the x will equal to 16. Divide by 2. So you got 2 to the x equal to 8. So x will equal to 3. Okay, once you got x equal to 3, then you can go and use this one here to solve. Okay, so 2 to the 3 plus 3 to the y equal to 11. So minus 8, right? 2 to the 3 is 8, so minus 8. So you got 3 to the y equal to 3. So y will equal to 1. So the answer will be 3, 1. Okay, let's go to the next one. Okay. You're looking for the largest integer n such that n is less than square root of 33 plus square root of 128 plus square root of 2 minus 8 reciprocal. Okay. So the key to this problem is you need to go and simplify these. Okay. So what you do is to simplify that, you go off to the side. So square root of 33 plus square root of 128. First, let's go and simplify the 128. So this becomes 33 plus square root of 128 is a square root of 2. Okay. So since that's a square root of 2, then what you want to do, you want to set this equal to a plus b square root of 2. Okay. So you can set this equal to a plus b square root of 2. Then you go and square both sides. So you're going to get 33 plus 8 square root of 2 equal to a squared plus 2ab squared of 2 plus 2b squared. Okay. Now all you have to do is matching the integer part with the integer part, square root part with the square root part. Okay, so you got 33 is equal to a squared plus 2b squared. Okay, and the square root part, you got a squared of 2 equal to 2ab squared of 2. So from here, that's going to divide by square root of 2. It cancels out. Divide by 2. So 4 is equal to ab. Okay. So 4 equal to ab. Again, you can kind of solve for a and substitute, but you're going to get messy. So it's better to just go and do trial and error. It's faster. Okay. So if you have a equal to 1, then b will equal to 4, or b equal to 4, then b equal to 1. Okay. And now we don't have to consider negative because the square root has to be positive, right? So, and therefore we don't consider the negative. Okay. Okay. So now you can go and try each one of these to see which one work. Okay. So if you try this one here, so you got 33 equal to 1 square plus 2, 4 square. Okay. And this one works. Okay. Then if you try this one here, okay, so you got 33 equal to when a equal to 4. Okay. So when a equal to 4, so you got 4 square plus 2 times 1 square. This one doesn't work. Okay. So the one you're looking for is this one here. So therefore, this is equal to so a equal to 1, so it would be 1 plus b equal to 4, 4 square root of 2. Okay? So that's going to substitute back in here. So this will equal to 1 plus 4 square root of 2. Okay? So once we get this part, now resume is not too bad. Okay? So it's going to get rid of that. So n had to be less than 5 square root of 2 minus 7 reciprocal. So n had to be less than 1 over 5 square root of 2 minus 7. And to simplify, go and multiply by the conjugate. So n had to be less than, and when you multiply this together, you get 50 minus 49. On the top, you get 5 square root of 2 plus 7. So n had to be less than 5 square root of 2 plus 7. The square root of 2 is about 1.4. So it's about 1.41 something. Okay. So n is about 7.2 plus 7. So n had to be less than 14.2. So the largest n can be is 14. Okay. Okay. So again, here's a key part. Learn how to simplify the complex radicals. Okay. So you can so from here you simplify this first, and then since there's a square root of 2, so it's not too bad. So you can just set it equal to a plus b square root of 2, square both sides, and you look for a and b. So once you find a and b, so that's your a, that's your b, right? Okay, let's go to the next one. Okay, 560. It says the ratio of interior angle of the two regular polygons is 3:2. Okay. And how many pairs are there? Okay, so you got two polygons. So let's go and call it polygon M, and you have the polygon N. Okay, so the exterior angle will equal to 360 divided by M, and the exterior angle for this one would be 360 divided by N, right? So the interior angle would be equal to 180 minus that. So interior angle would be equal to 180 minus that. And then the ratio is 3:2. Okay, so that means 180 minus 360 over M over 180 minus 360 over N. So this to this equal to ratio of 3:2. Okay, now you have complex fraction. So to simplify complex fraction, you multiply by common denominator. So common denominator is Mn. Okay, so you're going to get 180 Mn minus the M cancel out, so minus 360 N, and this would be 180 Mn minus the N cancel out, so it would be 360 M equal to 3/2. Okay. And the number is kind of big, so I'm going to divide everything by 180 on this side. So factor 180 and reduce. Okay, so you got Mn minus 2n over Mn minus 2m equal to 3/2. Then after that, I'm going to cross multiply. So cross multiply is over here. So you got 3Mn minus 6m equal to 2Mn minus 4n. And so I'm going to move this over. So minus 2Mn on both sides. So Mn minus 6m equal to negative 4n. Go and factor the m. Okay, and then go and divide. So m equal to negative 4n over n minus 6. And I'm going to switch the negative. So m equal to 4n over 6 minus n. Okay, so now let's go and do trial and error. So let's go and make the table. So n and m. Okay, now for regular polygon, the smallest one, the least size, the lowest side is triangle, equilateral triangle. So n had to be, either one of these had to be at least 3. So if n equal to 3, then m would be 4 times 3 over 6 minus 3, and this would equal to, so this is 3 cancel with equal to 4. Okay, so in this case you get the 4 and the 3. So you get a square and equilateral triangle. Okay, when n equal to 4, okay, you get 4 times 4 over 6 minus 4. So this will equal to 2. So 16 divided by 2 give you 8. Okay, so you're going to get the octagon and the square. Okay, so you're going to get octagon and a square. And then if you go 5, so you got 4 times 5 over 6 minus 5. So this will equal to 20. And so this would be icosahedron. So 20 and the 5 and the pentagon. So you got 3 possibles. So answer would be 3. Now you cannot go 6 because 6 you're going to get 6 minus 6 is undefined, right? So n cannot be 6. It only can maximize 5. Okay. Okay. So you get 3 possible ways. Okay. And that's it.